Yeah, hi, good morning. I want to introduce the lab, which is going to be the refraction of light or bending of light, and is going to be here. Of course, when you go to the learning models, you will be able to access the handout, which is about refraction of light. You will open the FET. This is going to be a completed formal lab report. You're going to have also an Excel sheet that should be submitted. Then you are going to submit the formal lab report as a Word document, and you will also as well submit the Excel sheet. Remember also to watch the whole period of this video in order to get the full credit. Now you are going to open, like this link is going to take you to the FET, which I will share with you in a little bit. And I will say first we are going to verify Snell's law and calculate the index of refraction of glass. Then I'm gonna be like jumping between the instructions, going to the FET, going to the Excel. First, you are going to set your first medium to be air and the second medium to glass. I want to use glass here. Use the laser view to be ray. I will show you also how to do this. Set the wavelength to 650 nanometers. And then enable normal line and angles. Turn on the laser source and then change the incident angle from 5 to 40 in steps of 5. And I want you to use the protractor in the toolbox to measure the angle and also to measure the intensity of light for the incident, reflected and refracted. And then you are going to design a table to input your data and record the refraction angle each time. Remember, the simulation is going to give you the angle in degrees, but we need to convert this into radians because Excel deals with radians only. You are going to graph sine theta 1 versus theta I, the incident angle, versus sine theta R, which is refracted angle. And you are going to use the graph to calculate the index of refraction of this type of glass. All right. Now, I will share with you. Okay, this is the, I would say the FET. Here on the left-hand side, you can choose between ray and wave. We're going to use ray, and this is 650. These are the tools. This is the protractor. This one is the intensity, and my first medium is air, and my second medium is glass. If it is not, you're gonna change. Okay. Here where you are, you will be able to calculate to change the medium. Okay, I have also here, the angle is not important because we're going to measure. The most important is the normal. Okay, here is when I have my light incident, I want to use my protractor here. All right, and then I want to have my first angle to be 5. Okay, this is my incident angle. This is the incident beam of light, and this is the refracted. Light is going to bend based on, the relative relationship between the indices of refraction of both. Usually for air, we are going to consider it 1. And for glass, it depends on the type of glass that we are using. What's happening always when light interacts with medium, that we will see that part of the light will reflect. Can you see? but the reflection here is very minimum, and we are going to say that most of the light is going to be refracted. I can check that using the intensity. If you look here, the intensity is 95.97. For the incident, it of course is going to be the 100. And for the reflected, you're going to find that it is just 4%. Okay, these you are going to actually record them in the table. Then after that, what you will do is you're going to increase the angle to 10 and measure again the refracted angle, measure the intensities, and go on. Okay, here I will show you my task 1. Okay, this is my angle of incidence, this is my angle of refraction. I did not record the intensities. You need to record them. Here what I did is I am converting my angles into what? Into radians. Then I said equals A1, my angle here, the incident, divided by 180 multiplied by pi. And this is my angle in radians. Okay, I found here a function that is sine of this. And then I did also the conversion for the angle of refraction. This is the column here. Then this here, I will say this is the angle in radians. And here also, this is the angle in radians. And this is sine 1, sine theta 1, and that is sine theta 2. After that, you will graph it. And this is sine theta 1 is going to be here. Sine theta 2 is going to be here. And the slope here, because Snell's law is verified, n sine theta 1 equals n2 sine theta 2. And then I can say, since n1 is 1, sine theta 1 equals n2 times sine theta 2. Then the slope of this graph from the equation here, you should be able to find what is really your index of refraction. I just want to go back to here, and I will say, don't forget to measure the intensity graph, use the graph to calculate the index of refraction of this type of glass. All right, now the second part, it is to measure the speed of light in different media. You can actually here, we're gonna do this for measuring what is speed of light in glass and also in water. Then we are going to repeat the process. First, we are going to set our medium to air and the second to glass. Again, repeated, we are going to have the laser view to be ray. We are going to set it to 650. Nothing special about it, by the way, but it's just, to use the same light. Use the speed meter from tools to measure the speed of light in glass. And I will say, use the indicated index of refraction to verify your results with the glass, speed of light in the glass. We know that N equals, which is the index of refraction, equals C over V. C, it is the speed of light in vacuum. And V, it is the speed of light in the material. Then you will be able, because you will be able here to find what is really the, let me show you, the value, index of refraction of glass here is 1.5. Then you should be able to calculate here what is the speed of light in glass. Okay, you are going to compare this with this one here, where is gonna show you what is really the speed of, 0.67 C. It is the speed. Then you should be able to do that calculation very easily. And this is for part 2. For this lab, don't forget there are values that you're gonna have them under data section, and some of the values that you should have them in the calculation section. Don't forget to include sample calculation for the lab. Okay, the last part here, we have here materials. We call them mysterious A, mysterious B. We are going to find what is really the index of refraction of these materials. And I will say we're going to repeat basically what we did in part 1. And we are going to measure the angles from 5 to 40. In 5, we are going to measure the angle of incidence, the angle of refraction. We should have at least set of these values, and then we are going to have a graph sine theta I versus theta R, and that is gonna give you, like, again, the slope is gonna give you the index of refraction of mysterious A and mysterious B. Let me show you here. This is where we're gonna have mysterious A. Okay, we don't need that. We don't need also the intensity measure here. We need only that protractor. And you're going every time to change your angle, find what is the refraction. List these values very similar to part A graph, and have your value for index of refraction of A and index of refraction of B. Now, this lab will not be due until, okay, let me check, because, okay, this is what is going to be, okay, we are going to have it this week, and next week is going to be the spring break, all right? Then, yeah, this is the refraction of light. Then is going to be, after also the break, we are going to have the exam, and okay, then I will say we can have it due by, let me see, let me check if I give it, oh yeah, I did not yet decide on that, but of course it's not going to be due, the spring break is going to be the week after. Okay, then yeah, you have more time to work on it. Then it's not going to be, of course, by the way, due by this coming Sunday, because is going to be already started the spring break. Then it will be the Sunday after. All right, thank you very much and have a great day.